Hello, we're going to do our video on free radicals and reactive oxygen species. So we'll go ahead and get started. So the first thing we're going to talk about, we're going to back up right to basics and talk about valence electrons. Valence electrons are the crux of the issue with free radicals, reactive oxygen species. So remember back in general chemistry, you were drawing an atom and you felt like you were drawing planets orbiting around the sun. What you did is you drew the nucleus. So you had your nucleus and you had some protons in there, you had some neutrons in there, and stuff like that. Then you started drawing these orbitals, it felt like, around it. And you had a certain number of electrons that could go in each orbital and things like that. So you did that, but you were really looking and focusing on this outer orbital and what was going on there. Everything happens there. It's kind of like, let's say, I don't know, you're talking about a company and you have the headquarters of the company. And then outside of that, you have, I don't know, a regional office, you have a warehouse, and you have a retail store. Well, the customer only interacts with the retail store. The customer will send their money in, take their goods out, that kind of thing. Everything's happening with that outside layer. All these other layers are in there and they're necessary, but to the outside, to that outside customer, they're not doing anything. So it's the same idea. We have our nucleus, we have a few shells, and then we have that outer shells. We have our inner shells, and we have that outer shell. That outer shell is what interacts with other atoms. And the way it interacts is with the electrons that are there. It's like so many things we talk about, it's always all about the electrons. So this outer shell wants to have 8 electrons. So it would like 8 electrons in there. How many electrons are in there? Go back to general chemistry, where remember you were looking at the periodic table and you were saying, depending on what group whatever atom is in, that tells you how many electrons it has and in what shell. And if the outer shell is full, then it's an inert. Um, if it's not full, depending on how many are in there, that determines how reactive it is and things like that. So it all comes back to that. Oxygen is the atom we're going to be looking at. It has 6 electrons in that outermost shell, but it wants 8. So the fact that it wants that 2 more electrons is really the crux of all this, where everything that's going to happen that we're going to talk about is coming from. Okay, so what we're going to talk about is free radicals first. So a free radical is an atom, molecule, ion, whichever, with at least one unpaired electron, valence electron in its outer shell. We make them in so many things that we do. We're going to go through soon a lot of reactions, processes, and everything. And they can make the molecules we'll be talking about making, and or they can make these free radicals. One in particular, the electron transport chain, a process we'll be doing about week 3 or 4 of next try, is really good at making these free radicals. So the oxidation reactions ensure that molecular oxygen is reduced to water. So that's going to get very important. This whole thing is based not only on that idea of the valence electrons and then want or need for 8 electrons in the outer shell, it's also based on our oxidation reduction story that we told. So remember, oxidation is losing an electron, reduction is gaining it. One molecule can't lose it without another one gaining it. You can't gain an electron without another molecule losing it. So it's all about oxidizing and reducing, except we're going to have partial reductions. So we'll talk about that and what that means in a minute. So what we're going to have, or where we're ultimately going with this, is to reactive oxygen species. And we often abbreviate them ROS. So we're going to be talking about reactive oxygen species. And they're things like the superoxide anion radical. That one's kind of the precursor to the rest. So that one causes a lot of problems. We have the hydroperoxide radical, the second one. We have hydrogen peroxide, plain old H2O2. That's the weakest of all of these. And we'll see how we make that, use it, and everything. Then we're going to have the hydroxyl radical. That's the one we're ultimately going to be talking about, or one of the ones we'll ultimately be talking about when we're talking about lipid peroxidation, which is really where we're going with this, what we're setting up for. That's the strongest one. We'll have our lipid peroxide radical, and we'll talk about how that and the hydroxyl radical interact. We're going to have, or we're not going to do anything with now, but another reactive oxygen species is nitric oxide. Another one is peroxyl nitrite. So like I said, we won't really be doing anything with those now, but they are something we will come back to and talk about later, probably next trimester. Okay, so we have some characteristics of these reactive oxygen species. They're highly reactive. No kidding there, that's kind of implied. They make new reactive oxygen species, and that's really where one of the damaging effects come from. One makes another, and they can get into these chain reactions. They have a short lifespan, characteristic, but not too meaningful. They can damage our tissues. That's the whole problem with them, and really why we're talking about them. They're not all bad, and I don't mean to make it sound like they are all bad. There are some functional free radicals, and like I said, this is some stuff we'll come to later. One of them we'll do today, but cellular signaling with the nitric oxide and everything we'll do later. Cellular defense and immune response, we'll try to talk about that at the end of this video. Okay, so we've got some sequential steps that drive this whole thing. So we're going to go through the reaction, go through the steps, and just look at electrons getting added. Because like we said, this is reduction and oxidation, gaining electrons, losing electrons. And we can start from oxygen, go ultimately to water, but these radicals are in between, reactive oxygen species are in between. And if we don't make the full trip to water, that's where we make them and have our problems with them. So what we're going to do is we're going to start out with oxygen. That's the molecule that starts the whole sequence. So if we add an electron to oxygen, we're going to get that superoxide that we were talking about. So we get the minus, and we designate the electron. So this is our superoxide. Then it's an anion, it's a free radical. Probably we should write that. Then we have another step in the sequence. We can add another electron. So we add another electron. and we get hydrogen peroxide. And we're going to talk about the enzymes that do this and the sequence and where you see it and everything a little bit later. But we get hydrogen peroxide in between. Then we can add another electron. Should have had a 2 there, I'm sorry. We can add another electron. Now we get that hydroxyl radical that we kind of don't like, and we'll talk about what it's going to do. We also get a water, so that's okay. So this is our hydroxyl radical. So this is the most powerful oxygen-free radical, the hydroxyl radical. Oops. Like we said earlier, hydrogen peroxide was our weakest. Then if we add another electron, that's when we get our water. So when you read in here, you got 2 waters. Here's our 2 waters. So back when we were talking about this and we said, oxidation is losing, reduction is gaining. So I'm gaining from end to end in this story, ultimately 4 electrons. So if I gain those full 4 electrons on the oxygen, I get to water. We get to where we need to be. It's the partial reduction, as in gaining not all 4, that gets us to these reactive oxygen species in between. So I gain 1 electron. I get my superoxide. I gain 2, I get the hydrogen peroxide. I gain 3, I get the hydroxyl. I need to gain that full 4 to get to my water and get to the end of the chain. So when you hear it's partial reduction, as in I don't get all 4, I get part of that 4, that's my problem that makes my reactive oxygen species. If I get my 4 full electrons, I'm good. I've gotten to water at that point. Okay, so there's a number of ways that we get these things, get these free radicals. Electron leakage from the electron transport chain. We're going to look at that next try when we do electron transport. Regular redox reactions, regular oxidation reduction reactions. Few other ways involving oxidases, coenzymes, things like that. We're not going to get to probably. You'll probably hit those in nutrition. Finally, a respiratory burst we will get to. Basically, we're going through these steps, these reactions to kill bacteria or kill other invaders in the cell. So we'll talk about that. So what causes these free radicals? Again, ultraviolet radiation, air pollution, things like that. So these can all lead to DNA damage, and these are all things that you'll see here and there in the curriculum. So this will cross over into several courses in different places in the curriculum. Okay, so let's now talk about the scavengers that scrounge up these free radicals and get rid of them. There's some important enzymes and important molecules in this. So this is the list of enzymes, or the first 4 are the enzymes that we're going to talk about. And remember, with our enzymes, we were talking about our enzymes that needed certain vitamins, minerals, things like that. That will come into this story. We'll talk about superoxide dismutase in a minute. We might see it in the cytoplasm. So cytosolic superoxide dismutase, that needs copper. We might see it in the mitochondria. Mitochondrial superoxide dismutase, it's abbreviated SOD. We see it in the mitochondria. Now we want manganese for it. So we'll see some of our vitamins and minerals here and there. Polyphenols, we're not going to talk about an awful lot. Dr. Krabbe will do that in your nutrition class. So let's talk about the reactions and where we use these enzymes, ultimately getting to less harmful molecules. So the first one, superoxide dismutase, is going to work on superoxides. So if I start out with two superoxides, plus a couple of protons, superoxide dismutase, like we said, is abbreviated SOD, gives me hydrogen peroxide plus oxygen. But I don't leave my hydrogen peroxide alone. So this is going to get into some reactions that we'll see next try when we've talked about glutathione. But what I'm going to do is I'm going to take that hydrogen peroxide, I'm going to do a couple steps, ultimately getting to water. But what I'm going to do is some oxidation reduction reactions. So I can't oxidize without reducing. I can't reduce without oxidizing. So I want to take my hydrogen peroxide. I want to go to water. So what I'm going to do while I do that is I'm going to take glutathione, the reduced version of glutathione. I'm going to oxidize it. So that was an oxidation, which allows me to reduce hydrogen peroxide to water. So that's my reduction. I don't leave the glutathione alone. I reduce it while I oxidize it I reduce it. Wrong end of the arrow there. Sorry. Try this again. Ugh. Reduce while I oxidize NADPH, which we'll talk about. It's not NADH, there's a P in there, to NADP. So the enzymes that do all these steps, we have for this one, glutathione, peroxidase, abbreviated POD. For this reaction, we have glutathione reductase. And we'll talk next try where we're getting this NADPH. We're actually starting out with glucose, and we'll go through some steps. We'll go through some reactions to make our NADPH. We're going to see our NADPH used in a couple of different places. And keep in mind, it's NADPH, not NADH. So they're two different molecules. NADH is the one that we're going to see more often. So our antioxidants, like we said, are compounds that protect the body from free radicals. So their protective mechanism is to scavenge up to remove those free radicals and get rid of them. Actually, let's go back for a second. We forgot catalase here. Okay, we forgot catalase. That's another one that doesn't fall into that little cascade we just did. So let's talk about that. What that one does is gets rid of lots of hydrogen peroxide. So if I have lots of hydrogen peroxide, I can also use catalase to go to water and oxygen. Okay, so let's go back to our antioxidants then. Okay, we have different actions, different types of antioxidants, and they might be preventative. They might prevent the chain reaction, and we'll talk about a chain reaction shortly. They might prevent a chain reaction from starting. So we don't get the free radicals, we don't start the chain. We might break the chain, scavenge them up to prevent the chain from continuing. We could also remove the peroxides. So 3 different ways of getting rid of them. Different systems. We have enzymes. We just talked about those a little bit. The superoxide dismutase, things like that. You have your vitamins and you have your minerals. We'll talk about those a little bit next trimester. I think Dr. Krabbe is going to talk about those a lot when you get to nutrition with him. Okay, respiratory burst. That's the last one we'll run through quickly. And this is a really fast increase in the production of the reactive oxygen species when we're trying to do phagocytosis, engulf a microbe and get rid of it. So it's an immune response. It can also be used for cell signaling. So what we're going to do is we have the microbe. There's something less than 5 microns, but whatever it is that we're trying to get rid of. We'll take the cell that's doing the phagocytosis, we'll engulf it. He'll talk about this in physiology. So this is one of the places that biochem and physiology kind of overlap. So we're going to take our oxygen, and this is the respiratory burst part. We're going to take it to our reactive oxygen species. So we still have NADPH, NADPH, going to NADP, and NADPH oxidase is the enzyme that does that. So this part, that's really the respiratory burst in the whole thing. Then the enzymes we've already seen kick in. Superoxide dismutase will convert that oxygen to hydrogen peroxide. Now we're going to add a chloride ion to the mix. So we're going to take that hydrogen peroxide, add a chloride ion, use an enzyme called myeloperoxidase. It's abbreviated MPO. And we're going to get hypochlorous acid, not hydrochloric. We've got the other oxygen in there. Hypochlorous acid. That then is what actually kills the microbe. So very similar story, similar enzymes, some of the same enzymes, but that's what we call the respiratory burst, and that's how the phagocytosis, or how our reactive oxygen species play into phagocytosis. And we'll stop there. We'll pick up in another video with lipid peroxidation.